Okay, what we're going to look at in this section is rational roots, or the rational root theorem, or the rational zero theorem, which says that if you have a rational root of a polynomial, then you take the factors of p, which is the constant term, and you put them over the factors of q, which is the leading coefficient. And it's really not a painful process. So if I'm looking at this first guy right here, my constant term is 12. My leading coefficient term right here is a 1. And so the factors of the constant term 12. And I would just say something like this. What times what is 12? Well, 1 and 12. What else makes 12? And this is plus or minus 1 and plus or minus 12. And what else makes 12? Well, there's 2 and 6. So plus or minus 2 and plus or minus 6. And what else makes 12? Plus or minus 3 and plus or minus 4. These are all the things that make 12. And we're going to put all those guys over all the things that make 1. Well, for us, that's going to be plus or minus 1 times 1. And so if we reduce this fraction down for an answer, all the possible rational roots, and rational roots are fractions, would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Those are all your rational roots for this first guy. So let's look at the second guy. We're looking at negative 10 and 4. So if I take my negative 10, what numbers multiply together to make negative 10? Well, I've got plus or minus 1. And then the other side of that would be minus or plus 10. So I just write it the same way. And then I would have plus or minus 5, or 2 and 5. So those are all the things that multiply that would make a negative 10. Over all the things that multiply that make 4. So again, that would be plus or minus 1 and 4. And then what else multiplies and makes a 4? And it's 2 times 2. So we would just write the 2 once. So what are all the possible answers here? Well, what you do is you look at all the different fractions you could get. So we'll look at like 1 over 1, 1 over 2, and 1 over 4. Like we look at all of those relationships. Okay? Then we look at 2 over 1, 2 over 2, and 2 over 4. We look at all those relationships. Then we do the same thing for 5. 5 and 1, 5 and 2, 5 and 4. And we look at all those guys. And then we look at 10 and 1, 10 and 2, and 10 and 4. So we look at all of these different relationships and write out all the possible fraction combinations. And this will take a little bit of ink, but it's totally doable. So we're going to do that right now. Alright, so when we look at all these guys, we're going to have plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 1 over 4. And that's doing your ones. Then we're going to have plus or minus 2 over 1, plus or minus 2 over 2, and plus or minus 2 over 4. And then we're going to have plus or minus 5 over 1, plus or minus 5 over 2, and plus or minus 5 over 4. And then lastly, we're going to have plus or minus 10 over 1 plus or minus 10 over 2 and plus or minus 10 over 4. Now, some of these guys will all reduce to the same thing. So if you'll pay attention, these guys right here are all in reduced form. So anything that reduces to 1, 1/2, or 1/4 we don't want. Well, I've got a 1 here and a 1/2 here. And then go to your next row. Anything that reduces to 2 we don't need. Well, I think we're all right on there. Anything that reduces to 5 we don't need. And that means that we can get rid of this guy. Anything that reduces to 5/2 we don't need, so we can get rid of this guy. And anything that reduces to 5/4 we don't need. And then anything that reduces to 10. So all of my possible rational roots for this problem then become plus or minus 1, plus or minus 1/2, plus or minus 1/4. It should be 1/4, not 4. Plus or minus 2, plus or minus 5, plus or minus 5/2, plus or minus 5/4, and plus or minus 10. So these are all the possible rational roots for my function 4x to the 4th minus x cubed minus 3x squared plus 9x minus 10. And there's a lot of them, but that's okay. It gives us a framework to start looking for zeros, which is what we're going to do next. Alright, so we want to find all the real zeros of the following function. There's two ways to do it. One is by finding the rational roots. And so to find our rational roots, we're going to take all of our things that multiply to 20 divided by all the things that multiply to 1. And so this is going to be 1 and 20, and 2 and 10, and 4 and 5, all over 1. All over 1. So we have all these possible ways to do it. And so since these are all over 1, you're basically going to have these numbers to check for what's called a rational root. Now, if a rational root is a zero of a function, and we're going to check this function, then we can do synthetic division on 1, -8, 11, and 20. We can do synthetic division on this with one of the rational zeros. And if we have a rational expression, then one of those guys is going to work. So I like to always just test things close to home. So let's just check 1. And we're going to do synthetic division with 1. And if we don't get it, we're going to keep going. And bring down that first 1, multiply, and add. And multiply, and add. And multiply, and add. And we got a remainder of 20. And 20 or 24. Since we got a remainder of 24, then we know that 1 will not work. And since 1 won't work, we're going to try again. But let's stay close to home. So let's try -1, and we'll check these guys. And when I do that, I have 1, and then 1 times -1, and then -9, and then +9, and then 20, and then, hey, looky here. So we get a remainder of 0. This is good. A remainder of 0 is good because that tells us that 1, it tells us that -1 is a 0. And if -1 is a 0, then from this we know x plus 1 is a factor. So now, keep in mind with synthetic division, we've lowered ourselves by 1 degree. So if I know that x plus 1 is a factor, I'm left with x squared minus 9x plus 20. And if I need to find all of the real zeros, then I can factor this guy right here. And if he factors, good. And if not, I'll use the quadratic formula. But I can now find, once I get to a squared, I can find all of the real zeros. And so let's just check. X and x, what times what is 20? That adds up to negative 9, and it would be minus 4 minus 5. So all the possible factors of my problem would be x plus 1, x minus 4, x minus 5. And I would set all of those equal to 0. So I get x plus 1 equals 0, x minus 4 equals 0, and x minus 5 equals 0. So x equals negative 1, 4, and 5. Now, another way that you can do this is graph it on your calculator. Graph your function on your calculator. And once you've graphed your function on your calculator, find where the graph crosses the x-axis and find all those places where the graph crosses the x-axis. So you can do this with your calculator or with synthetic division. Okay, so we want to find all the real zeros of this given function, and again we're going to go p over q, which is going to be 12 over 10. So this is going to be a lot. 12 could be plus or minus 1, plus or minus 12, plus or minus 2, plus or minus 6, plus or minus 3, and plus or minus 4. That's a bunch. Over another bunch, plus or minus 1 and plus or minus 10. And then plus or minus 2 and plus or minus 5. So we're looking at all the possible rational zeros. Okay? And to give you a short list, you could get plus or minus 1, plus or minus 2, plus or minus 3, 4, 5, 6, and 12. That's all over 1. And then you could get plus or minus a half, plus or minus a fifth, plus or minus a tenth, plus or minus 2/5, plus or minus 3/2, plus or minus 3/5, plus or minus 3/10, plus or minus 4/5, plus or minus 2/5 we've already got, plus or minus 6/5, and plus or minus 12/5. I think that's all of them. All these. We have to check all of these. And if there's a rational root, it'll be one of these guys. Well, that's a lot to check. And so, graph this thing. Graph it and get an idea, and we can narrow it down to some possibilities. And so when you look at a graph, you want to graph and find where it crosses the x-axis. And if you want to go ahead and punch into your calculator to find where it crosses one of those x-axes, you can get a 0. And if you want to practice trying to figure out exactly how this works, then take one that looks close. Like say, negative 3/2 looks like it might work when you look at a graph. So list off all the values. And we don't need the plus 12 or plus 7. And then do your synthetic division. And so 10, and then 3/2 times 10 is negative 15. Negative 26 becomes 39. And remember, you're multiplying and adding all the way through. Multiplying and adding all the way through. And then 7 plus 9/2, so that's 23 over 2. Go ahead and keep a fraction in there because sometimes fractions are easier to work with. Not always, but usually. And then you're going to end up with 64 over 9. So guess what? You're going to have a remainder here. And your remainder is negative 21 fourths. So 3 halves, not a 0. So another one that's looks like it might work is negative 1 half. So try that guy. And again, we'll try with negative 10, negative 11, negative 42, 7, and 12. Bring down the 10 and multiply. So that's going to be negative half, or negative 5. And then 8. And that would be negative 34, which would be 17, which is 24, which is negative 12, and we get a 0. So what we've got now is 10x cubed minus 16x minus squared minus 34x plus 24. Okay, so let's just give ourselves a little more room. And then what I'm going to do now is trying to figure out with my new function, I can use my new function, my reduced function, and it's got all the same possible zeros. Those don't change. But I can do synthetic division with what I've got to see, and I can use what I already know. Like I know that negative 3 halves won't work. So if negative 3 halves doesn't work on the first function, it's not going to work on this one. And again, just look at the graph and try and get an idea. And it looks like the graph crosses the x-axis between 0 and 1. And we just used 1 half, or negative 1 half. But so let's try like positive 1 half. It looks like it crosses in between 0 and 1. So we'll go 10, negative 16, negative 34, and 24. And so when I do that, do your synthetic division, you get 5, negative 11, negative 11 halves. That would be negative, let's see, negative 60, be 64 over 2, 68 over 2 for 34. So 68, 79 halves. This is not going to work, I can already tell. So positive 1 half won't work. My other option was 3/5. So we can try 3/5 and see if that works. Alright, so go ahead and list all your coefficients off here. So it's 10, negative 16, negative 34, and 24. And we'll try the 3/5. It's got to be 3/5 or 1 half based on the graph that we're looking at. So if I come down here with 10, 3/5 times 10 is going to be 6. And negative 16 plus 6 is negative 10. So this is going to be negative 6. And negative 34 plus 6 is 30. And then, let's see, 40, negative 40. And then 3/5 times negative 40 is negative 24. So looky here, we found another 0. And this is good because now we've gone from a cubic to a quadratic. So we have found 2 of our zeros. 3/5 is a 0. Negative 1 half is a 0. And since we've got a 4th degree equation, we can either factor this guy or do the quadratic formula. And then we found all of the zeros. Well, I don't think this guy's going to factor, but we can look at it. So if I've got 10x squared minus 10x minus 40 equals 0, this would be, I could factor out a 10. X squared minus x minus 4 equals 0. So that would be x squared minus x minus 4 equals 0, because I can divide both sides by 10. So if I divide both sides by 10, this is what I get. And he won't factor. So we're going to have to use a quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And this gives us 1 plus or minus the square root of 1 plus 16, 17 over 2. There's my other two zeros right there. So the zeros for my problem are 3/5, negative 1/2, 1 plus the square root of 17 over 2, and 1 minus the square root of 17 over 2. There's all of my zeros. And so this is what x equals. Now, another thing that you can do is you can graph and find zeros. And I got a video for that on my channel. So you just search out and find the calculator that you've got. And you can use that to help you find the zeros as well.